All right. Hi, everybody. Thanks for joining me again tonight and finding your way back over to YouTube. The Zoom experiment last night went well, except for the video didn't get recorded, and I don't really want that to happen again. And it was meant to just be an experiment. So we're back on YouTube today. We are going to switch to Zoom long term for the next cohort, but we need to work out that problem with the video first. So we're back here tonight. We're going to talk today about custom data types. Specifically, we're talking about two things: structs and classes. And this is where we start to get into some of Swift's real power. This is probably the first topic that I would call more than just the bare basics. And so it's really important. It's also pretty darn cool. And I'm excited to teach it to you. It also might be a little harder to wrap your mind around than some of the stuff we've talked about so far. So I want you to be patient with yourself. I want you to realize that this is hard stuff you're learning, and it's okay to struggle a little bit with it and to take some time and to not completely get it at first. And that's normal, and that's why you have help from PMs and from me. And so be kind to yourself as you work on it. Okay, so I'm going to share my screen, get an Xcode window up, and I'm going to create a new playground, and I'd like all of you to do that too. And I'm going to call this custom data types. Make sure I set it to manual mode early on. And I'll go ahead and make it big. Okay, so what are we talking about here? What are custom data types? Well, we have spent the past week and a half talking about a lot of different stuff in Swift, but we've always dealt with types that Swift gives us. So we've used int and floats and doubles, and we've dealt with strings, and we talked about arrays and dictionaries yesterday. And these are all types of data that Swift has built-in support for. But in a lot of programs we write, we want to be able to represent the data we're working with in different ways. We want to be able to create our own custom data types that work best for the problem that we're solving. Imagine you're dealing with a contact manager app where you're storing data about people. It would be kind of nice if you could have a type that represented a person's contact information, their name and their email address and their phone number and their address and whatever else. Of course, you could store that in a dictionary. You could even, store a bunch of strings in an array and somehow figure out how to make that work, but it gets a little bit messy. It's a lot nicer and cleaner, and will make our code easier to read and easier to deal with and easier to write new functions in if we can have our own type. So that's where custom data types come in. There are several different kinds of custom data types in Swift. We're going to talk about two of them today, and I think they're the two most important. Those are structs and classes. And we're going to talk about the differences between structs and classes, but they have a lot of similarities. And we're going to start with structs. So struct, S-T-R-U-C-T, is short for structure. And a struct is just a value that includes multiple properties, as well as functions that go along with the properties that it has. So how do we create a struct? Well, we say struct, and then the name of our struct, in this case, I'm going to call it person. This is going to be a struct that represents a person. And then we give it properties. What are properties? Well, properties are just data that is part of an instance of that struct. So every person is going to have a name. So we want them to have a name property, and that will be a string. And we're going to give them an age. And the age should be an int. And if you look at this looks pretty familiar. It looks a lot like a variable with a name and a type. And we're not setting it equal to something. We'll talk about how you can do that in a minute. But that's because these don't have fixed values. It's because we want to, every time we create a new person, we want to give it a specific name and age. So this is at the most fundamental level, this is a struct. Now, this is not a value. This is sort of like a template or a blueprint for how to create a person struct. We call this a struct definition. What if we want to actually Well, so before I go on, we can also add methods here. Methods are really just another name for functions. So we create them using the same function syntax. And I'm going to call this introduce, meaning introduce yourself. And all it's going to do is print out, my name is, I'll talk about this self.name in just a second. My name is so-and-so, and I am such and such years old. Right now, we call this a method. Method is a function that is part of a type, part of a struct or a class, as we'll see later. And you only call this on a type. Now, you've actually seen methods before, and a couple of you asked about them yesterday because they were a little bit strange. But if you use append or remove or index of or count, well, count is actually a property on an array. But if you use any of those functions on an array, what you're actually doing is calling a method that was defined on the array type in Swift. So methods have access to the data that is part of the instance that they're being called on. So if we say self.name, it means I want the name that is attached to, that is part of the same person that is having introduce called on it. And the same with age. And the self is just to indicate, it means, me or this thing that is the current one in the context of this function running. It turns out you don't actually have to say self dot. The Swift compiler is smart enough to sort of just figure it out. So most of the time you can leave it off as long as it's unambiguous. So as long as it's clear to the compiler that name here means the name property and age here means the age property, you can leave it off. And I usually will. So I would actually write this like this. But if you like it better, if you think it makes it more clear, you're welcome to leave self dot there. There are some people who think that that's the better way to do things. It's just a matter of opinion. All right. So I want all of you to follow along in your own playground. If you haven't already done this, yeah, it's okay if you wrote a person already, but let's write a struct for song. Watch the questions better. Okay, so let's write a struct for a song. Like, imagine we're writing a music app. What properties might we want a song to have? Well, I think the first obvious one is a title. That would be a string. Probably an artist. Also a string. Probably also an album, the album that the song's on. And I'm actually going to make this a string optional because not all songs are on an album. Maybe it's released as a single or whatever. So that one I'll leave optional, and you can do that. So go ahead and write this. We're going to use this for other things later on. Okay, so that's cool. There's our song struct. I've already got my person struct that I wrote, and I'm going to keep working with this as I show you some more stuff, and then we'll kind of come back to this song struct. So we've now got this blueprint or this template for a person, but what if we want to actually create a variable that holds person? Well, we can do that too. And so I'm going to create a variable called friend, a constant actually, constant called friend. And I say equals, and then how do I actually create one of these person things? Well, you say person, the type you're trying to create, and then open parenthesis, and then you see you get, it's like a function with arguments for each property. I can pass in a name, which is a string. I can pass in an age, which is a number. Now I have an instance of person. We call this an instance of person. This is not a blueprint, right? It's a specific instance of a person. It's like if you're building a house, you have a blueprint for the house, and that's one thing. That's like this struct person here. But then construction workers, or you, if you know how to build a house, I don't, use the blueprints to figure out how to actually create a physical house that you can live in. That's kind of what we're doing here. We're saying take this blueprint for a person, and I want one of them that's a real thing with this name and this age, and then assign it to this variable. And now we can do stuff like print out this person's name, and if we do that, that works. And we could also call a method on it. So we could say introduce It says, my name is Ellie and I'm 30 years old. So that's pretty cool. Let's look at something that might be interesting. What happens if we try to change this person's age? So we want to, they had a birthday and they turned a year older, so we want to say age equals 31 now. I think that will work. No, it says cannot assign to property friend is a let constant. Well, that might be what you expected, right? We've seen this before. We saw this with arrays, we saw it with strings, we saw it with numbers. If we declare something using a let, make it a constant instead of a variable, we can't change it. And sure enough, that works here. We can't change friend's age. So what do we do to make it so we can change friend's age? Because sometimes we want something where we can change its properties. Well, just as before, we make this a var, and then we can. And now if I do friend.introduce, and then do it again after we make the change, you'll notice that the first one prints my name is Ellie and I'm 30 years old. The second one prints my name is Ellie and I'm 31 years old. So the change did exactly what we expected it to do. But it only works if we make this a variable instead of a constant. Okay, let's have everyone add some code to let's actually create one of your songs. So let's say song equals, and then pick a song you like. I am gonna go with Hello Submarine by the Beatles, which I think is on Abbey Road. No, that's Octopus's Garden. I can't remember. It's on Sgt. Pepper's, probably. So now we've got a song. What if we want to change it? What if we want to change our song? What if we want to say, well, I like Yellow Submarine fine, but I like it better by, I don't know who's covered Yellow Submarine. I'm sure lots of people have, but I don't know. Maybe Metallica did a version of it. I don't think so, but that won't work, right? So try this. Try this on your song. And it doesn't work. You get an error. But if you change this to a var, it should work. And now we don't get an error, and we could even print song.artist. It did what we expected. So that's sort of structs in a nutshell. They're a thing that can contain properties and methods. You create a blueprint. You say any song must have these properties and these methods. And then to actually create one, you do this. We call this instantiating, but what we're really doing is calling an initializer. And we're going to talk in just a second about initializers. And you can only modify a struct's properties if you make the variable that holds it a var instead of a let. Well, where did this come from? This looks kind of like a function, right? It's called pretty much like a function, except that you just call the type directly. But it has arguments, and it's used to sort of set all these properties in the struct. Where did that come from? Well, this is what we call an initializer, and it's sort of like a function, but it's a special function that is on every type, every struct, and every class and other types that exist in Swift. But instead of just doing whatever, because functions can do whatever you want, initializers have a really specific purpose, which is to take to create a new instance of this type and initialize it, set all of its properties to whatever they're supposed to do any kind of setup that needs to be done, anything that needs to happen right when a new thing is created. An initializer is responsible for that. Structs are nice because you get an initializer for free most of the time, as long as you just have some some pretty simple properties. The compiler will just create an initializer for you with arguments for each property. So we just automatically got this initializer with title, artist, and album. We call this a member-wise initializer, and the reason we call it a member-wise initializer is because you could also call these member properties of song. They are properties that are members of song or belong to song. So member-wise initializer means an initializer that has arguments for each of the properties of something. If you hear that term, don't get confused by it. That's all it means. But what if we want our own initializer? What if we want to be able to create a do something custom? For example, maybe I want to provide a default value for something, or maybe I want to calculate something in my initializer. There's lots of reasons you might want a custom initializer. Maybe I'm going to add a favorite color. This, and I've heard that the most common favorite color is blue, so I want to make that the default. For creating a function, we can add a default value for our arguments. How do we do that for an initializer and a struct? Well, we get one free from the compiler, but if we want to do some customization, we can just create it ourselves instead. And an initializer in Swift looks a lot like a function with some key differences. What are the differences? Well, for one thing, it is always called init. This is not just any old name I want. It has to be called init for it to be an initializer. That's just short for initialize. And you also notice that it does not have a func in front of it. So you don't put func in front of init. That won't work. The compiler knows that init is this special thing. Other than that, it looks like a function. Still has a list of arguments that are written the same way in parentheses. I'm going to give the favorite color argument a default value of blue. Still has braces for the body. And what are we doing here? Well, you can kind of do whatever you want, any kind of setup you need to do. But at the bare minimum, we need to give these properties values. These are not optionals, right? So if we create a person, they better have values. There's no way for them to be nil because they're not optionals. So one of the jobs of an initializer is to set any of the non-optional properties. And luckily we have values for each of those properties because this gets given a name, an age, and a favorite color, or else, otherwise it'll just be blue if they don't provide one. So how do we actually set them? Well, we're going to use the self.syntax syntax again to say, I want to set the property called name. We can't actually leave it off here because then these have the same name. I want to set the property called name to this name that was passed in. That's why we use self.dot here. This is actually a different thing than this. This is the value that was passed into the initializer as an argument. This is the actual property on the struct. And we'll do that for age. And we'll do that for favorite color. And there we go. We have an initializer. And now if I want to say that somebody has a favorite color, I can do it. And it works. I'm going to add that here too. If I run this, it should work. And so that's good. I can also leave this off because we gave it a default value. So that's we customized our initializer because we said, well, we don't want to have to specify a favorite color, and we'll just use blue if there isn't one. And so if we do that, it works. And sure enough, it's blue. So structs give you a member-wise initializer by default, but there are still reasons you might create your own because maybe you want a somewhat different argument list, or you want to add default values, or you want to do some calculation in your initializer. There's lots of different reasons, and those will become clearer as you write more code. But if you want to create your own, you just do it. You just write it yourself, and it looks like a function, except it's always called init, and it does not have func in front of it. So Abby asked about putting lets in your structs, and you got some answers on Slack, which are right. You can, and there are reasons to, but if you make a property a let, it can be set by the initializer, but then after that it can never change, even if the variable it's in is a var. So if I change this to let, this code won't work anymore because it'll say cannot assign to property age is a let constant. This friend.age won't work anymore. Sometimes you actually want that. Sometimes you want a property that cannot change after initialization, even if the variable is a var. But I would say, as a rule of thumb in your structs, always make things var, because it's better to let yourself, as you write later code, determine whether you want to make something changeable or not at this level. There's a lot of nuance there, but that's what I would say is a good rule of thumb. Okay, so let's go back to our song up here. Go ahead and create a custom initializer for this. We're going to make it so that album is optional because it's already optional, but we're going to make it so you can leave it out of the initializer by giving it a default value. We can't do that right now. If I take this out, so I don't know what album this is on, and I take that out, it won't work. It'll say missing argument for parameter album in this call. You need to put album right there, but it's optional, so I shouldn't need to say it. But that's just how the like free default initializers for structs work. They expect you to include all of the arguments. So instead, let's create our own, and we'll say, and follow along with me. We'll say init title string artist string album string optional equals nil. That way, if they don't pass, if they just leave album out altogether, we'll just assume that they want it to be nil. So now we can do self.title equals title, self.artist equals artist, and self.album equals album, and we're done. Now, even though we've left album off, this should work, and it does. So I'll give you just 30 seconds to catch up with that and finish writing this yourself. Okay, I think probably all of you are caught up. Jeffrey has a good point in Slack, and I've tried to be very consistent with this as I've been teaching today. If I haven't done that, I'm sorry, but if I've made mistakes. But yes, inside of a structure class, a variable is called a property, and a function is called a method. And those terms mean something. A method is a function that is part of a type, as opposed to just a function that's off on its own. And a property is the same idea. It's a variable or a constant that is part of a type, not just off on its own or part of our program. So I know that can be a little confusing, but get used to that terminology. And I think being precise in your terminology is valuable for lots of reasons, but it's valuable because it makes you an effective communicator when you're trying to communicate complex concepts where the details matter. It also makes you sound smarter. If you're out applying for a job, and if I'm your interviewer and you consistently use terminology wrong, I tend to think, well, maybe they don't actually know this stuff very well. So please try to be pretty what's the right word? Serious about that, about getting that stuff right. It does actually matter. Okay, so let's move on. We've learned how to create a struct and initialize it, and even create a custom initializer. What about classes? We're going to move on to classes now. So what is a class? I'm actually going to delete all this. Or not. I don't remember if I'm going to use song again, so I'll leave that here for now, but kind of clear my screen off. Comment this out so it doesn't clutter up my log. Okay, so what is a class? Well, class is another kind of custom data type, and it's pretty similar to a struct. Just like a struct, classes have properties and methods. Just like with a struct, a class definition is a template for creating an instance. And even the syntax for creating classes is really, really similar to creating a struct. However, there are some important differences between structs and classes that we're going to talk about as we go on. But first of all, why don't we talk about how to create a class? So I'm going to do the same thing I did before with a person, but this time instead of making it a struct, I'm going to make it a class. Before I do that real quick, Daniel, you need to unwrap it. If you're going to print it and not want to see that it's optional, you need to unwrap it with an if let. Okay, so how do we do this? Well, it looks exactly the same as when we created a struct, except that we start with class instead of struct. And that's it. and we give it a name, and then braces, and then inside the braces are all the properties and methods we're going to give it. And I'm going to give it the same ones: name, age to start with. I won't do favorite color, but so this looks exactly like the struct we created above. Commenting this out just to make sure that there's no confusion. What happens if I build the app now or try to run it? I know I haven't done anything except create this, but we just want to see if it'll compile. And it doesn't compile. It says class person has no initializers. Well, here's where we hit into the very first difference between classes and structs. In a struct, if we just added some properties, we didn't need to create our own initializer. We talked about how we could if we wanted to customize it, but we didn't have to. The compiler gave us one free. That is not true of classes. So in a class, you have to create your own initializer. And so, but luckily it's not really any harder than what we saw for creating a custom one on a struct. It's just that we have to do it even for the simple case. So I'll create one here. Does the same stuff inside as what we did in our struct. Now that we've done that, our playground should at least build, and it does. So just for the sake of future work, why don't, if you've still got your song class up, why don't you change it to a class? Notice that everything else should still work. Just changing it to a class is fine. It'll still print Metallica and do what you thought it was going to do. That's the only thing you should have to change. There are other differences between class and structs, but for right now, you'll see that they behave very similarly. Okay, so going back to person now. How do we instantiate one of these? Well, you probably already figured this out because your song just kept working. But same thing. It's the exact same syntax as for a class. You call the initializer by just putting parentheses right after the type and passing in the parameters it takes. Assign it to a variable. You're good. Okay, so let's try changing friend's age to 31. The struct that didn't work. Let's see if it works with a class. Well, it didn't give me an error. What happens if I print it? For that matter, what happens if, well, I didn't add the introduce method. I could have, but I just didn't. What happens if I print it? Sure enough, it changed to 31. I'll comment this out again. I just don't want it in the way. Well, that's weird. It's a let, and it let us change it. This is the first major difference we're going to talk about. I mean, the not including the initializer is one thing, but it's actually a pretty small incidental difference. It's not a fundamental behavioral difference. But the first big difference we hit into is that we can create a class with let, and it still lets us change its properties. And that's pretty surprising if you're used to everything we've done so far, where if you make something a let, you can't change it. And this gets at one of the fundamental differences between structs and classes, and we're going to get into some more depth on this a little bit further in the lesson. But you can change a class's properties even if you make it a let. Now, so what's the point then of let versus var for a class? Well, you still can't change which instance of person is stored in this variable. So I cannot say friend equals some new friend. If I try to do that, it'll complain. It'll say cannot assign to value friend is a let constant. So we can't put an entirely different new person in here because it's a let. If we made it a var, we could. But we can change properties that are part of that person. So this is a little bit complicated, and it's just something you have to get used to and remember. Let's go back up here. We already changed our artist to Metallica. We've made this var, but let's change it to a let. And you should all do that with your song and run it. And you'll probably notice that it works fine. You should notice that it works fine now because we just went over that. Classes let you change their properties even when they're a let. So that's the first big difference. I'm going to give you all a challenge, and I want you to spend about 5 minutes on it. step-by-step instructions, so it should be pretty easy. I'm going to post it in Slack, and then I'll talk about it. Maybe I'm going to post it in Slack. Give me just a second. I'm trying to get the step numbers to copy, and they're not, but I will get it to work. All right, so in the iOS June 11th channel, I've just posted a challenge. If you are watching this with the self-paced option, you can also find it on the curriculum site for today's module, which is custom data types. And if you scroll down to the learn to instantiate classes objective, all the way at the bottom is the challenge. So here's the challenge. Create a struct called bottle, or water bottle, call it whatever you want, that represents a bottle of water. Give it two properties, a volume, which is the size of the bottle, and a water level property, that is how much water is left in it. And don't worry too much about units. Like say we're talking about liters. Create and water level should probably be a float, because you could have a fraction of a liter in it. And then create a let constant called bottle1 and assign a new instance of bottle to it. I guess I should just show this on the screen. That's the smart thing to do, right? So create a struct called bottle, give it volume and water level properties. Create a let constant called bottle1, a variable, not a variable, but a constant with let called bottle1, and set it equal to a new instance of bottle by calling bottle's initializer. And just pass in whatever volume and water level you want. Maybe 1 liter and half of it, it's half full, so 0.5 for the water level. And then use a print statement to print the water level. Now here's where things get interesting. Create a second variable called bottle2 and assign it to bottle1. So just do var bottle2 equals bottle1. Use a print statement to print water level in bottle2, and then change the water level in bottle2 to something else, and print it again. And you expect that it will change, right? Sorry, then use a print statement to print the water level in bottle1 again. And what happens? Does it change? Does the level in bottle1 change to what you just changed the level in bottle2 to, or not? So answer that question. Figure out how that works, and then change bottle to a class and give it an initializer, because you'll have to do that, and see if this behavior changes. See if the same thing happens again. We'll reconvene in exactly 5 minutes. I'll leave this up on screen, and we'll go through this. And if you have any questions, post them in Slack as always. Sorry, I had to run out and get a drink. So sorry, I'm slow in answering your question, Serena. The problem is if you just try to print person itself, you'll kind of see something weird like that. Instead, and also I'm not sure why you're printing person, because I don't know. I just don't know why you're doing it. But um, you need to print the properties of person. Basically, the compiler doesn't really know how to print, doesn't really know how to turn a whole person object into a string. How is it supposed to do that? There is actually a way to tell the compiler how to do that, and we're not going to talk about that today unless we have lots of extra time. But normally you'd want to print out its individual properties. Maybe use string interpolation to print a nice string like we did in the introduce method that we wrote before. So Lotana says, and I hope I'm saying your name right. I'll have to get the pronunciation from you. Um, you're asking about initializing, just the correct syntax for it. So the syntax is always just the type and then parentheses. So other methods, when we call them, we do a dot. We do dot something, something, something. Okay, I'm glad I got it. With initializers specifically, because they're kind of special, we just do the type and then parentheses and then the arguments that are in the parentheses. And this whole bit of code right here creates a new person with this name and this age, and then we're assigning it to friend. And so I'm not sure why you're getting errors. I can't see your code. But if you can't figure them out, make sure you ask in the next hour, because that's definitely something you want to figure out how to do and figure out what's causing the problem. My guess is it's pretty simple. As you have probably already figured out, little typos cause big problems in code, and especially when you're starting out, typos are easy to make and sometimes hard to figure out. And that kind of never goes away. They get easier to figure out as you get more experience, but they don't get any harder to make. You keep making them. So that's my guess. Okay, it's been about 5 minutes, and I'm curious to know what you found. Does anybody want to summarize what you saw when you did the challenge on Slack? What happened the first time when bottle was a struct and you created bottle 1, then you created bottle 2 and assigned bottle 1 to it, and then you changed bottle 2's water level. What did you see when you printed bottle 1's water level after doing that? Did it change too, or did it stay the same as it had been when you initialized it? Yeah, Jake, we're gonna get into that. I just want the answer to the challenge though. So Daniel said it stayed the same. And that's what I expected. Let's try it. So if I write struct bottle, I do var water, well, I did volume, make it a float, and do var water level, float, and I say let bottle 1 equals bottle. I'll make it a 1 liter bottle with half full. I can print bottle 1 water level. Get rid of that Metallica again. At 0.5, just like I expect. And then I'm going to say var bottle 2 equals bottle 1. I'm gonna change. Well, I'll print bottle. Well, I'll change bottle two's water level, say to 0.25, so drink half of it. And then I print bottle two's water level, and then I'll print bottle one's water level again as well. So bottle one starts out at 0.5, and then we create bottle two, and it's a var, so we can change its properties. But we just stick bottle one in there, and then change bottle two to 0.25, which works. When we go look at bottle one again, it's still 0.5, so it didn't change. So it's almost like bottle two is a completely separate bottle. And that's how structs work. That's right. So what if we change this to a class? So Vitaly says, yeah, it stayed the same in the struct and it changed in the class. And that's exactly what I was hoping you would see. So if I just need to create an initializer here because classes don't give us one. Volume equals volume and self.water level equals water level. Now, if I run it again, I see some different behavior. Now, bottle one does change when we change bottle two. So that even though it was a let, right? Well, we already established that classes can still have their properties changed even when they're lets, but we're seeing even something beyond that here. We're seeing that with a class, when we assign bottle one to bottle two is bottle one. They're the same thing. And so this is the biggest, most important difference between classes and structs. Structs are what we call value types, and we'll talk about we can talk more about what value types means in just a minute. And classes are what we call reference types. So when you have an instance of a class in bottle one, you don't actually have the value that is that class. You have a reference to it. So it's like bottle one refers to this particular bottle. I've heard it described as, imagine you have a post office full of post office boxes, and when you say bottle one here, you're actually just talking about a post office box number that has a bottle in it. And then when you assign bottle one to bottle two, you're saying go look in the same post office box and go find that same bottle and use that. So when we change bottle two, because it is pointing to the exact same instance of bottle that bottle one was, bottle one is also affected by that change. Structs work differently. With a struct, we have what's called a value type. When we assign a struct to a new variable, this right here actually creates a brand new copy of bottle one. It creates a copy of bottle one with the same properties and everything, but it's not the same instance. It's a new copied instance, so that when we change it, has no effect on the original one. And this is really important. This is why we have structs and classes in Swift. Sometimes you want reference behavior. Sometimes you want the behavior of classes. You can pass the thing around through your entire app, and any part of your code can change it. Any part of your code can see the changes, and that can be valuable in certain cases. But it can also cause bugs, because what if you have lots of screens in your app, and you have this same instance of a class that you're passing around, and you're using it throughout your app, and on one screen the user changes the value, but then they go back to a previous screen that they thought was displaying different information, and it's changed over there. You can end up with bugs. And so Swift also has structs, and in some sense structs are a little safer because you can kind of use them throughout your app. Variable that is a struct, you get a copy, so you're not going to accidentally change some information that you had created earlier without meaning to affect it. This gets more and more clear the longer you work with it, but for now, just remember this behavior, and also remember that a struct is a value type, and a class is a reference type. That is something that why we choose those terms becomes more clear as you learn more about how things work under the hood. For if anybody here has any experience with C or sort of low-level programming, classes live on the heap, and structs, well, at least conceptually, live on the stack. So that's part of the difference there. Jake asked, what's the point of having different instances of reference classes since they're all the same thing? That's a great question. And usually you wouldn't do something like this, just this simple in code. But let's look at another option. Let's say we have, did I remove it? Okay, so let's say we have a function called change name to string new name of person. We'll create a person class. Give them a name. I'm only going to give them a name right now. Say init name string. Now in my function, I say person dot name equals new name. And then I call it. So I say let person equals person, and I call this person, say Matt. And then I say, and I'll print their name. And then I call this function. Name Ben, change it to Ben. And then I'll print their name again. And if I run this, their name changes. I passed it into the function, and the function was able to change it. This might be good. This might be something you want. And a class will work for this. And in this code, we actually do have two different, you call it instances. That's not the right term. We have one instance of person, but we have multiple references to it, multiple variables that represent it. We have, well, or constants in this case. We have this constant here that we created right here. And then in the function, this is actually another constant. It's not the same as this person. We could call this anything, right? We could call this foo. It would still work fine. So these two things are not the same. We pass this in and say, hey, function, use this as your foo, but it's not actually the same variable. If we change this to a struct, behavior changes. It won't work. And it won't work, well, it won't work for more reasons than just that. It won't work because structs don't work that way. When you pass a struct into a function, you are making a copy of it. This person gets assigned to this foo constant, which is the argument for the function, this one, and a copy gets made because that's how structs work. Anytime you assign them to a new variable, a copy gets made. Classes, when you assign them to a new variable, a copy does not get made. You have a reference to the same instance. I hope I answered your question, Jake. I feel like this is pretty difficult to explain and pretty difficult to understand the first time you see it. Some of it becomes more clear just the more code you write. But anyway, I hope I answered your question. We're gonna talk about one more thing before we finish up. I am going to talk about something called inheritance. This is a big, giant topic, and we're not going to be able to get into as much detail as you want to learn over your entire career in the last 10 minutes, but I want to introduce you to it. So, what is inheritance? Inheritance is something that only classes can do. This is another difference between classes and structs. Inheritance means, and this is one of those fundamental ideas in object-oriented programming. Many of you have probably heard the term object-oriented programming. It's programming that deals with objects. And by the way, both the structs and the classes we've been dealing with are basically objects. An object is just a thing, a type that has both properties and methods. And object-oriented programming has been around for 30 years now. It's probably the most common programming paradigm now. Swift has object-oriented features, and a lot of the other popular languages are object-oriented languages like C# and JavaScript and Java, and Objective-C is the objective in Objective-C is object-oriented. C++ is object-oriented. Ruby, Python. You can think there are lots of object-oriented languages out there that are very popular. There are also some that are relatively popular that are not object-oriented. C is an example of that. JavaScript is only kind of object-oriented, although it's becoming more so as time goes on. So one of the fundamental ideas in object-oriented programming is inheritance. This means a class can inherit from another class. So the easiest way to explain this is with some code. Let's create a class called animal. And an animal, let's say that an animal has, we'll say a number of legs. I think I actually, yeah. Actually, we'll say species. So it has a species, number of legs, and a Boolean that's just whether or not it has a tail. We'll give it an initializer. And just for fun, because we can do it, let's make it so that there's a default of false for has a tail. Probably the wrong default, because tons of animals have tails, but I'm going to do it anyway. Set all the properties in here in our initializer. Also going to give it one method called vocalize. This is just going to say, for now, it's just going to print I'm and then the species. So we discussed before that a class is really just a blueprint. We could create any animal we wanted out of this, right? We could say, let snake equals animal, and it's a species. I don't know what's this. I don't know what species. There's lots of different species of snakes, and I don't know what one is. Whatever. I'm just going to call it a snake. It has how many legs does it have? Well, it has 0 legs, and it does have a tail. It's pretty, but it's pretty generic, and we could even call snake.vocalize on it. If I run it, that should work. It says I'm a snake. Sure enough. Okay, but what if we want to specialize a little more? We can't call slither on this snake. There is no slither method, even though we know snakes can slither. Well, we could create a whole class that represents a snake. We could add new things to it. So we could add a property for color, for example. And we could add a property for is venomous. We could create a new initializer for that stuff. Most snakes in the world, by the way, not that I'm an expert on snakes or anything, are not venomous. So we'll give it a default value of false. Okay, so this is great. Now we can create a snake. You can make it green and say that it's, or even just leave the is venomous part off. We could even add a slither function. A method. But now what about this other stuff that we had for all animals, species, number of legs, and has tail? Well, it'd be nice to have that on snake as well. And so inheritance allows us to do this. We can say, I want to create a class called snake, but it's a descendant of, or the term we actually use in programming is, it is a subclass of, it inherits from animal. And what that means is that it will get all of the properties and methods that animal has, but can add its own and can also customize the ones it gets, as we'll see in a minute. So how do you do that? You say class and then the name of your class and then a colon and then the thing you want it to inherit from. So in this case, I want it to inherit from animal. So this means create a class called snake, make it a subclass or a descendant of animal, and then add these things to it. But it still has all of the things we started with. Now we can still say snake.vocalize, and that will actually work. This won't compile, and we'll talk about that for a minute. But in a minute, oh, I forgot to do this. It is venomous. Still shouldn't actually compile. So there is still a problem here, right? There are these properties on animal that are not optional. You have to set a species, a number of legs, and has tail, and that's what this initializer does. But when we create a snake, we're not setting any of those. So in order to do that, we have to call the other initializer. When snake gets initialized, we also want to call this initializer and make sure all of these properties get initialized as well. And you do that using super.init. Well, I actually want all of them because hasTail is going to be true. Super.init, and you call the Superclasses Initializer. That's what super is short for. Superclass. Another word for that would be parent class, the class that snake inherits from. And you pass in all of these. So the species is going to be snake, number of legs is going to be 0, and hasTail is always going to be true. And we know these are fixed in this case because these are just always true for all snakes, right? If we needed to. Some of them were not. We could add additional parameters here and pass them in, but we don't need to do that. So now this will run. And the vocalize method works. We didn't create a vocalize method in our snake, but it inherited the one from animal. It still has it. And we could print out number of legs, and that'll work. And again, number of legs didn't come from snake. It came from animal, which it inherits from. So this is actually pretty powerful. What if we want to make a snake? Snakes don't really say, I'm a snake. They hiss, right? We can do what's called overriding. So this allows us to customize the vocalize method and any method that we inherit from our superclass. We can say, well, I want, most of this stuff, but there are some of these things that I want to change. I want to change their behavior a little bit. So in this case, we want to make our vocalize method do something slightly different. But you can do that by writing it again and putting override in front of it. This just means I want to override, or in other words, change the behavior of the vocalize method. I can say print big long hiss. And now it hisses when we call vocalize, and it doesn't run this code anymore. It runs the more specific code that is in the snake subclass. Yeah, but sometimes we might still want this behavior. Like we might want to do what vocalize does and then add stuff to it. And we can still do that. We still have access to the original one. We can say super.vocalize, which means call the superclass or the parents class version of vocalize first and run that, and then I'll do whatever I want to do after that. So if we do that, it will now say I'm a snake and hiss. So this is actually really powerful. It allows you to put base functionality in a base class and then inherit from that class. And we can add more subclasses. So we could create a dog subclass, and a dog might have might have a breed and might have a name, and we could add an initializer for this too. That's not what I meant to do. And we could say name equals name, and then call super init and pass in, Canis familiaris. I do actually know what the species of a household dog, a pet dog is. Has 4 legs, has a tail. We could create our own vocalize. We could, again, override vocalize and say print woof. And then this is also, it's a different kind of animal. It's still going to get all of these properties and methods, but it also adds its own, and then it also overrides vocalize, and it does something different than what the snake did. So if we create a dog, and we say dog vocalize, the dog will use its vocalize method. It will woof instead of saying I'm a dog. And we can also print out properties on it, like number of legs, and it should be 4, just like we thought. So this, we've only scratched the surface of this, and you'll see how this gets used in real code as we go along. But I just want to open up an Xcode project that we worked on before. So this is the palindrome checker from a couple nights ago. And if you look at viewController.swift, we haven't explained this yet, but it's a class. It's called ViewController, and it's actually a subclass of UIViewController. UIViewController is a class that is given to us by the iOS system framework, specifically by UIKit. Anything that starts with UI is part of UIKit, which is the system library that has all of the stuff that you need to make an iOS app UI. UIViewController has tons of functionality. It knows how to put things on the screen. It knows how to animate on and off. It knows how to deal with, transitioning to another screen, etc. And instead of having to write all that functionality every time we create a screen in our app, we can just inherit from UI view controller. We get all of it free because it gets inherited from UI view controller. And then we can add the things that we want to add. So we only have to add a little bit of code. We get all the stuff that UI view controller does for us free. And there's some stuff that we can override, like ViewDidLoad, which we'll talk about a little bit tomorrow. ViewDidLoad is a function or a method on UI view controller that we can override, and this will get called. We always want to make sure to call super. The base one, UI view controller itself, might want to do something in its ViewDidLoad, but we can say, hey, I loaded. And now our version of ViewDidLoad will get called when the view loads up and appears on the screen. So this whole idea of inheritance is very powerful, and it is the basis for all of this free functionality that we get in our iOS apps, not having to write it all ourselves. So that's why it's really cool, and that also makes it so that you can understand this a little bit better. Okay, so that's all we have. I have not been watching Slack very well, so let me see if there are questions. Okay, so Lotana asks, how would you create the snake subclass if you wanted to omit the number of legs property and add a new property called rattle? Well, that's actually a weakness in inheritance, in subclassing. It is actually possible to do that. I would have to look up the exact specific syntax to remember. You can actually mark this as unavailable. Might be at available. Look it up and tell you later. There's a way to mark it as unavailable, but it's a little bit of a hack. The real way to do this is don't do it. If you're inheriting, that's one of the downsides, is you do get everything that comes with the parent. And if you don't want number of legs, well, too bad, you get number of legs. Okay, so Daniel said, can you make a subclass within a subclass? You absolutely can. We could make a new dog class called Chihuahua. That is a subclass of dog, which is itself a subclass of animal. And we just like we would call dog the parent of Chihuahua, we would call animal the grandparent of Chihuahua. And we could add, I don't know, what would we add to Chihuahua? Well, we could add our own init that doesn't actually even take any parameters, and it just calls super.init Chihuahua and name. I don't know, what's the good name for Chihuahua? Whatever. Now if we create just create it, we don't even have to pass any parameters in, and it'll work, and it'll be able to vocalize, and it'll have, has tail, and it will have number of legs, and those will all just work. We run it, they all work. So the question was, though, now in Chihuahua, like let's say we wanted to override vocalize, we print like yip yip or something. All right, I'm sure there's some Chihuahua owners among us, but I don't like Chihuahuas very much. But I'm trying not to make fun of them. What if we want to still print I'm a Chihuahua, or I'm a dog, or whatever it is we're doing? You actually can't. That's actually a weakness in inheritance. There is no, at least in Swift, there is no super.vocalize. You can't do that. You can only go one level up. So you have to think about that as you're designing a class hierarchy. But this actually gets us into a bigger question, which is this a good idea? And there's, just people have learned over the past 30 years of writing object-oriented programming, one of the kind of hard-won lessons by people who have written a lot of it, and this goes for me because I've certainly made this mistake in the past, is that inheritance is both great. It's both a blessing and a curse. It's actually really a double-edged sword. So if, it can solve some problems in a really nice, elegant way, but it can also get unwieldy and cumbersome. And one of the biggest ways to make object-oriented programming not work well for you is to make class hierarchies that are deep. I start to have to second guess myself if I'm making a class hierarchy that's deeper than one level. You start going down 2 or even more levels, and the biggest one I can think of that I ever made is probably 6 levels deep. And it was a mistake. Things become hard to maintain for the exact reasons you're seeing. You don't have a way to access grandparent or great-grandparent or, heaven forbid, great-great-great-grandparent classes, and things become fragile, and you end up having a hard time figuring out where to put functionality that's going to be shared between multiple cousins, you might say. And So be wary of deep class hierarchies. It's easy to learn about this and think, oh, I'm going to use that everywhere. It's super cool. And then it's actually a mess. Is it possible to override properties? It is. Yes, it is possible to override initializers. So we could in dog, for example, we could override. I don't know. We could override the initializer. I don't know what we'd do in here, but whatever. Ignore this basically, and then still call. To come up with why we would actually do this in this particular case, but there are definitely reasons to override an initializer, and yeah, you absolutely can do it. You can't do it that way. You have to do it this way. Oh, yeah, there's lots of restrictions if you do this. You have to initialize all of the properties that are declared in the subclass. That's going to include name as well. Before you call super init, and then if you want to change any of the things that super init initialized, you have to do that after you call super init. So there are these rules, but you can do it. Okay, so I want to briefly discuss your project for tonight before I sign off. The project is, I'll post the link in Slack. It's also on the curriculum site. It's also github.com/lambdaschool/structs and classes. And you're going to build a little contact manager app. So it's going to allow you to enter and view contact information for your friends. Call it friends or whatever you want to call it. Basically, what you're going to do is add two text fields, one for the person's name and one for their phone number. It's going to have a button that says create contact. And then a text view. So you type in somebody's name and their phone number, and then you hit create contact, and it saves that information and it puts that in the text view. And you're just going to make it so that it prints all of them in the text view. So every time you create a new contact, it kind of refreshes the text view and prints all of the contacts that you've entered so far in the text view. We'll talk tomorrow, by the way, about how to do a list, like if you went into the real contacts app and you have a nice scrolling list. That's what tomorrow's lesson is all about. But for now, you're just going to put it in a text view. And you're going to do this with structs and classes. So create a struct called contact and give it name and phone number properties. You're going to create a class called contact manager that is responsible for managing or handling all of the contacts that the app is dealing with. I think this is the closest you've gotten so far to a real app that is actually pretty useful. You still got some UI stuff to learn, and we're going to cover some of that tomorrow. But it's starting to be something you could actually use to help you in your real life. So I hope you have fun with it. There's also a bonus question. The bonus is, if you want another challenge, make it so that it only shows one contact at a time, and there are like forward and backward arrows to scroll through them. I just thought that would be a nice challenge. So make sure you get help from your PMs. Please do join the discussion groups in the third hour. And thank you so much for being with me again tonight. Tomorrow's our last night. I'm excited. See you guys tomorrow.